again, it does weird things, but it is kind of funny. So I think it tried to repost it. So again, that's why it's kind of entertaining to watch. For today's video, we're going to be taking a look at a repository that lets you control an Android phone using a local agent, in this case powered by Qwen2.5 VL, Microsoft's OmniParser, and the Android debug bridge, of course, along with an Android phone. So let's jump right into it. Here we can get our first look at the phone use agent repository, and now I suppose is a decent time to mention that I did make this because I've really wanted to have something like this, and given how OmniParser works so well and is pretty cool, especially in conjunction with Qwen2.5, which I actually got my first experience with using Microsoft's OmniTool and OmniBox and things like that, so I figured it wouldn't be too much work to actually translate this over into just controlling an Android phone using ADB, which is kind of the command line tool which will allow us to actually control the phone from the computer through the instructions sent by Qwen, which will obviously make a little bit more sense as we progress into installing this repo. However, it is kind of simple. You can see that I have the Claude generated SVG diagram here, which makes this very legitimate. And on top of that, if we scroll all the way down, we can see that this is experimental, which oftentimes is a catch-all for something that may or may not work. So with that, we're basically just going to talk a little bit about this repository, and then we'll go ahead and run through the steps to get it installed and running, and we'll play with it and see. It sometimes can perform some funny things, and sometimes you quickly want to like close out of it because it's opened the phone and it's like trying to dial something or to call back like a spam number that you ignored. So it's entertaining to say the least. So let's just talk a little bit about the architecture of this, as long as some prerequisites to actually run it, and then we'll go ahead and play with it. This does use vLLM as the backend, running Qwen2.5 VL 3B. I actually had the best luck with this model. I do have a version of this that works with Ollama. However, I was having a lot of trouble keeping the model like having memory of its previous actions. So I tried it with Gemma 327B, and it really did a good job of actually navigating around the phone on any specific screen, but I didn't get it configured properly to actually remember the task at hand. So that is why for now we are using vLLM's backend with Qwen2.5 3B. Basically what this is you give it a prompt like open Chrome and search for weather in NYC, which is how I've been testing this. It basically goes ahead and sends that to the Qwen model. However, this chart is kind of a little jank, truth be told. So what happens is it sends that. OmniParser actually takes a screenshot of the phone through ADB. ADB takes a screenshot of the phone, which then gets parsed by OmniParser, and it draws bounding boxes around it as well as some like output about what each element is and the element ID. Following that, the Qwen model basically takes the prompt as well as the response from OmniParser with the kind of bounded objects and things like that. Being a multimodal model, it can actually see that as well, and it decides what action to perform, and the actions are actually handled using the ADB bridge as it's listed here, which basically just means that we use ADB to actually send an action to the phone. So like if you say tap or swipe or enter text, it will actually do that on the physical phone that is connected by USB to the machine using ADB. So that is just kind of like a quick little run around of how this actually works under the hood. Now that we have a bit of pertinent information about the actual structure of this repository and how it works, we are just going to jump down and begin the installation for this. Our first step is going to be to install ADB, which is the Android debug bridge, and this is what will actually allow our computer to perform the autonomous actions on an Android phone as if we were there and actually physically performing them ourselves. To do that, we are just going to do sudo apt install ADB. Now, I already have this on my computer. However, if you don't, it will just go ahead and install it. And once that's done, we are just going to verify the installation by running ADB version, which will show you the version of ADB you have, as well as the location of where it has been placed. Following that, our next step is going to be to clone this repository and get everything set up. That is the setup with OmniParser section right here, but to be honest with you, this is worded a bit awkwardly, so I will probably just change the wording right here. But we're just going to jump to the section after installing ADB on Linux. Step one is just to clone this repository and then change our current working directory into the cloned repository, which we can do quite simply. Our next step, while perhaps not the best practice, is just, it's something that worked, so I kind of stuck with it, and that is to actually clone Microsoft's OmniParser GitHub into the phone use agent directory here. So basically, we're just going to run this command once we're within the cloned phone use agent directory, which will then clone OmniParser into our phone use agent folder or directory. And once that's done, we will basically be done with the kind of weird step of step 2. Our next step is just to create and activate a Conda environment named phone agent using Python 3.10. I did design this and test it all with Python 3.10, so I have just stuck with using that for good measure, I suppose one could say. And we just copy paste this here, which will go ahead and create the environment and then activate the environment. You can see I already have that on the system, but pretend I don't. So pasting that command in will just go ahead and create the environment and then place us into the activated environment named phone agent, as we can see right here. Now the next step again is perhaps akin to step 2, where maybe not best practice, but unfortunately the dependencies here outlined in the requirements.txt are quite verbose. And what I mean by that is there's about like 250 of them. And unfortunately, the only way I could get this working reliably on a fresh install like this was to just freeze every dependency that was in my working environment that I developed this in. So that led to a kind of verbose requirements.txt file, and I do want to ASAP concatenate this so that everything is much shorter and easier to install. With that, we are just going to do the typical pip install-r requirements.txt, which will likely take a little bit of time. And this is where I do want to also outline that I've only tested this on a 3090 Ti with CUDA version 12.4. So again, I don't know how well these packages might play together on your specific system. So there may be some troubleshooting and like version kind of headbutting, if you will. I don't know that I've ever heard that term used before. I don't know why that came to mind first, but I just wanted to outline that. And this is something that I will quickly look to kind of improve. So once all of the dependencies have been installed, our next step is going to be to download the weights for OmniParser and then place them in the correct location, as we see here in step 5. And I do quickly just want to note that this is essentially the exact same steps that are outlined in Microsoft's OmniParser repository right here, where we just make sure we have the correct weights and that they are in the correct location. So with that, we are just going to copy paste this command right here, which will change our directory into the OmniParser directory that we cloned inside of our phone use agent directory, and then go ahead and download and place the weights for OmniParser in the correct location. It is only like a gig or 2 gigs of files, so it shouldn't take too long at all. And once step 5 is completed and the weights are correctly downloaded and placed, we are just going to hop back up to our phone use agent directory. And this really kind of concludes the initial setup steps in terms of actually getting this cloned onto our local machine in the correct directory structuring. With that, our next step, as we see right here, is device configuration. And essentially what this is when we are going to be using an attached Android device with this, we need the specific screen resolution of that device we're going to be using, because if we had the wrong screen resolution, it would end up trying to click in the wrong place or things like that. So the alignment of where we're actually trying to press would not work at all. So fortunately, instead of having to Google search our specific device and then like scroll through a bunch of slop, we can just use ADB to actually tell us what the resolution of our device is. Now, keep in mind that I have this physically plugged into the computer right now, and if I didn't, the ADB commands here would not work because there would be no devices listed. On top of that, you do actually need to have developer mode enabled on your Android device, and USB debugging also needs to be enabled. There is likely a plethora of good resources out there on how to enable developer mode. It just kind of revolves around going into your settings and then scrolling down to the build number of Android and then tapping it 7 times or something, which will enable developer mode. So quick side note there, but prerequisite as well. But assuming we have our phone plugged in and developer mode is enabled, if we do just want to actually check if it's recognized, we can type ADB devices and it will start the daemon if it's not running. And we can see that the devices attached does show a specific device in the list, which is our Pixel 5 right here. So with that, we can just run this. ADB shell WM size, and it shows us the actual screen resolution of our phone, which is 1080 width and 2340 height. So now that we have that, assuming yours is actually different, you will need to go into the config.json here and actually change the resolution to reflect your specific device. So you would just go into the phone use agent folder. You would open the config.json right here. And then you would actually just set the coordinates or the resolution to what you saw from the shell output there right here. But pretty simple step, and once that's done, you are all set to make sure that the automated taps actually show up or happen in the correct location on your device. So with that, our next step is actually to go ahead and pretty much start using this. Now, the first step here will actually be to have the weights for the model we're going to be using downloaded, which vLLM will automatically take care of when we run the command to start this whole process for the first time. So I would pretty much recommend actually trying this step 4 right here through the command line first and foremost. There is a graphical user interface or a Gradio web app in which we can then later use this. But while we do not have the Qwen2.5 3B models downloaded, my suggestion is to do this through the terminal so we can actually see the file downloads in process and then verify that they correctly occurred. So that's exactly what we're going to do right now. As we scroll down right here, we just want to make sure our Conda environment is activated, which it is as denoted by the phone agent right here in parentheses. And our next step there is just going to be to actually run a task. And essentially, if we had everything set up already, this would actually go ahead and autonomously open Chrome on the phone and then type into the search bar weather in NYC, and then it would likely occur in far sooner than 10 steps, so it would then probably just start tooling around and doing weird things. But that's what the max cycles flag right here denotes, is how many times it will try to complete this action. You may be like, well, what if it completes it first? Can't it tell that it completed it and then stop? And to that, I'd say experimental. So though, all right, I've gone on a little on a verbose rant. I apologize. We can see that when we run this for the first time without the model weights downloaded, it will go ahead and actually download the model weights and everything needed for the specific Qwen model we're going to be used, which by default is the 2.5 VL 3 billion parameter version. So it'll take a bit of time, but once that's done, we'll actually be able to see some stuff happening. So once all of the model files have been downloaded by vLLM, you will see your VRAM utilization start to spike, which means that it's been downloaded correctly and it is now starting to load the model into the graphics card. And basically, it is pretty slow to actually load the model. That is just kind of, it's a 3 billion parameter model, but it's pretty heavy. So I know that's probably not a scientific way of putting it, but it's not the fastest thing on the block. And that is partially why I wanted to have OLLAMA working, because then you can use like pretty aggressive quants of something like Llama 3.2 11B Vision. But for now, I actually had the best luck with the Qwen Vision models, even the 3B one, where it would actually go ahead and kind of work. So when this kind of does all of its vLLM setup here, like compiling the CUDA graph or whatever it's doing right here, it will then actually go ahead and start to take screenshots through ADB from the phone, use OmniParser to parse them, output the bounding boxes and things like that. And then in conjunction with our prompt, as well as some of the system prompts we are passing to the Qwen model, it will go ahead and then try to perform the actions. The reason I keep looking over my shoulder is to see if the phone is actually starting right now. So we can see that the terminal output here says the screenshot is saved. Then we will see a log output of Qwen's decisions and what it wants to do. So basically, I'm holding the phone. We can see, oh, you can't see crap, sorry. I didn't touch it, and it just went ahead and opened Chrome right now. I don't know how well you'll be able to see this screen, but basically what should happen now is it will tap into the search bar, as we just saw right there, and then it will enter weather in NYC. Now, entering text through ADB can be kind of funky, so I had to just put like weird spaces in between them so it didn't get like janky, but we can see, okay, it did weather in New York right now. It entered that in. And really, like, this was the threshold of where I was okay with actually putting this out into the world, was if it could open the browser on the device, enter something into the search box, and then search it. And we can see that it actually correctly did do that. So now here's where, okay, like that was cycle 4. It should probably just be like, hey, I correctly did this. Here you go. The logic there is not quite right. So being that it will go for 10 cycles, it may just start doing random stuff, but that can be kind of funny. Just don't do it on a phone maybe that has like your bank logged in or can send money to people, because I'm not trusting a 3 billion parameter model to not make a mistake. So, okay, it is now clicked on an X link or something at NWS Mount Holly. And this is, again, it does weird things, but it is kind of funny. So I think it tried to repost it. So again, that's why this is, it's kind of entertaining to watch. And again, it's not the fastest thing. So we're on cycle 8 right now, and we'll see what it does or what it's trying to do. Okay, need to tap first to focus the text field. So we'll get into this more in a later section, but basically one of the things I needed to do, and a difficulty I noticed, was with the phone, it would just try to enter text into a text box. But obviously on a touchscreen device like a phone, you need to actually select the text box you want to type into prior to typing. So I kind of had to just manually kind of enforce that in its behavioral structure, one could say. But okay, so it is kind of just like, this is where we left off. But as we saw right there, I really hope the camera captured the phone screen here, or else I'm going to look like a weirdo just holding like some glary like mirror basically. Sorry, I'm getting excited by this. But it now shows task completed successfully in 10 cycles, which really by the 4th cycle, if it had stopped there, it would have been better. But we can implement like some human in a loop feedback mode or something like that. But if we go into the phone use agent folder right here that we cloned, that we ran this from, if we click on the screenshots directory right here, we will see that it first outputs like just a screenshot it takes, and then the one next to that will actually be the annotated version, which is the screenshot with the bounding boxes drawn around it through OmniParser. So basically, I hope you can see, but so for example, it identified, okay, there's Chrome, which would also be element 6. And that's something cool about OmniParser, is it also gives you more information about what it's seeing sometimes. Like, we'll get into that later, but, and then you can see, okay, here's the unannotated, then the annotated one has all of the bounding boxes, and then this was basically its process that we just saw. So we now basically have this set up and correctly running. And the next thing we can do is just basically go and do this through the Gradio web interface, which is obviously far more aesthetically pleasing than trying to do it with the command line. But for the first time, when we also need the model weights to be downloaded for the Qwen model, I like doing it through the command line because we can actually see and make sure that everything was correctly downloaded and installed. So the final thing I'll show for this section right here is just that if we go back into the phone use agent folder right here, you will see the main log, which basically will just log all of the actual actions. So like we can see here, step 3 seemed like it, or cycle 3 seemed like it was a good, and you can see it has its thought process and reasoning. The user wants to search for weather in New York, so I need to type the query into the search bar, etc. And then it does that. It shows like where it wants to click and things it needs to do. So that's just what the log is for. This log right here shows up empty. Don't ask right now why, but so yeah, we'll do the web interface now. So now we're just going to go ahead and try the web interface by running Python UI.py. Something I want to make note of is the phone left off right here where it was trying to repost that tweet that it clicked on. Sometimes if you leave the browser on the same page that it left off at, it just won't work really when it tries to open the browser and search fresh. So I always recommend just leaving it in like a fresh tab like this and then just closing the browser. So when it does open the browser, if it does, it won't like mess up, if you will. So I'm just going to put the phone back down and then run Python UI.py. And this will go ahead and start a Gradio web interface. Sorry, I kept sharing on, I'll change that to false so it doesn't give the live link as well. I just had to do that because I was debugging this from a remote machine. So if we control click on this right here, we will be met with a Gradio web interface, which is a little buggy. Now, I had a manual refresh button set in, so basically you would have to manually click this to have the screenshot and log refresh. I implemented something to refresh every 5 seconds, but for some reason it sometimes here says like connection lost. So I don't know, but the connection's not lost. So we are just going to execute a task right here, which is basically what are the instructions we want to autonomously perform on our phone. 8675309. We'll do some Tommy two-tone drawn prompt. And then we start the task right here, which will go ahead and basically do what we saw previously, where it goes ahead and loads the Qwen model, but it will give us the log output here as well, which will refresh every X seconds. I think it's 5 right now. And then once it actually takes its screenshot, which takes a little while to get the first one because vLLM has to load the model and everything else needs to happen, but it will actually show us our current screen there and we'll refresh every 5 seconds. So we'll just kind of give it some time and then see what it does. I don't know that this will work. Well, I don't know that it will successfully dial the correct number. We haven't really done too much testing with dialing numbers. I just kind of did web use first and foremost. All right, so we can see that in the log now here after the model has been loaded, it is running OmniParser and hopefully successfully. If it does so, it will then output the screenshot of the bounded boxes here. And sorry, it is the screenshots are way too big because they're the resolution of the phone, which is actually quite large, but it is how it is for now. And then we can see just some of its output here. The goal is to open the phone app and dial 8675309. A phone. Okay, so for some reason it's gone into the App Store. But it is, I mean, like, it's autonomously navigating around the phone. So, and then we just see that this refreshes every 5 seconds trying to perform the action we want it to. And then also, like, just sometimes seeing its log output here is especially actually pretty helpful for troubleshooting. Like sometimes if I, instead of saying open the browser, was like launch or something like that, it would actually return a command trying to use the launch tool or something like that, which obviously didn't exist. So there were a few ways to actually get around this, but one of them is just partially a limitation of the small model we're using, in addition to the fact that I'm not using like some well-documented backend for actually executing function or tool calls. Realistically, using the OpenAI agent SDK, where every action that it can take would just be like a Python function, would be better. But this worked well enough. So I think it's searching 8675309 in the App Store. Okay, and it's now just typing it again. And again, like I said, I basically just wanted to make sure it could open the Chrome browser and search something, and that was the level that I found acceptable to release. So it is experimental, of course, and instead of just giving it like instructions to open the phone app, blah blah blah, I'm just going to keep it very light and just say dial this number. So we start task, and then of course it takes a little while to load the actual model and everything, but once that's done and we get our first OmniParser parsed screenshot, it will appear right here, and then we'll be able to kind of see what it ends up doing. So we should see our first screenshot show up there in the current screen box. So it did open the phone app properly right here, which is good. We'll see what it tries to do. Now it's trying to search contacts. It typed Q. I'm not quite sure why it typed Q. It's now typed what? I don't know why it has typed what. Now it typed what? Yeah. Oh, did it delete that? No, I just... All right. Well, again, it's pretty apt at actually like opening the browser and then... Oh, I screwed this up. All right. So it is pretty apt at being able to actually like at least launch the browser and do stuff. We can see there that it did correctly identify and click on the phone icon. And again, this is kind of like a cobbled together example with a very small vision language model behind it. So now I quickly want to just go over some of the actual scripts, at least at a very surface level, and just talk about what they do in this workflow. I've tried filming this now a few times, and it usually ends up becoming like 30 minutes, which I don't want to happen. So apologies if I kind of go faster here. Main.py, as we see, is the entry point for the phone agent with the Qwen model. It sets everything up and just kind of begins the process, if you will. Now you can see right here that it loads the configuration from the JSON file, which we have right here. Now, device ID can be left null if you have only one ADB device physically connected to your machine, because if it sees that, it will just automatically choose the first device connected or shown in the ADB list. Next, and very important, as we saw in the repo, this is the specific screen resolution values for the device we're using. So these are for a Pixel 5. If you're using something else, you will need to change these to reflect your actual device. Then we just have the model path and some OmniParser configurations as well, which these were pulled directly from Microsoft's OmniParser Gradio example. So these are just kind of what was default loaded with their web app example. With that, we have the Qwen VL agent, which just basically handles our Qwen integration along with some vLLM stuff as well. And a couple things to note here. One of them is right here on line 33, where we have the GPU memory utilization value. So setting this right here to 0.80 says, okay, vLLM, you can use 80% of the available VRAM on this card. Now, OmniParser also uses video RAM. You can set it to actually run on CPU as well, but I have not tried it with that, and it will be much faster being run on GPU. So this value, depending on the actual device you have, may need to be tweaked, either set lower to have a little more overhead for OmniParser as well, or set higher if you're running out of memory trying to run Qwen. So again, I can only guarantee that I've tried this on a 24 gig card, but I would imagine you could get this working in a smaller card, but I don't know for certain. So, and then, okay, we create our vLLM instance, and then we have our system prompt for the Qwen model, which is kind of just guiding it with what it needs to do and what available actions it has that it can return. Now, being that this is 1, kind of experimental, 2, a pretty small vision model, and 3, not using any well-documented thing like the agents SDK from OpenAI or anything like that, it won't always really adhere to this, where basically we can tell it like, okay, valid actions are tap, swipe, type, and wait. For example, sometimes it would just try returning a click action, which obviously didn't exist. And I noticed that it will sometimes try to return the action listed in the actual user prompt. So if I say to it, execute this action, it will try to return an execute action instead. And that's just kind of a limitation of a few different related things here. But we'll talk more about that in a second, and then we have just kind of the rest of this, the instructions, creating the Qwen messages and things of that sort. So this kind of just handles vLLM and Qwen as one. So now we have our phone agent script, which is kind of like the heavy lifter here. And really, this is kind of the simplest way. This uses Qwen2.5 VL to analyze the screenshots and control the Android phone using ADB. This kind of handles the actual actions being sent to the phone through ADB to perform whatever Qwen dictates it should, and as well as getting the actual screenshot of the phone through ADB and things like that. Now, it also does kind of control some of the initiation of OmniParser as well, in terms of like starting it to parse whatever screenshot. However, that's not really the main thing I want to focus on with this script. It is the execute action function right here on line 303. So remember previously when we looked at the Qwen agent here and we said, okay, the system prompt, it won't always correctly return some valid actions. So for example, it kept trying to return a click action, and instead of just trying to make the prompt more robust here and things like that, which can cause inefficiencies in other places, it was just easier to manually transition that action from click to tap. So if it did return a click action, it would just kind of be read through ADB and the script as a tap. Now, if you're having a specific use case with this where you're having it do something else and it keeps returning a weirdly named action when it should just be returning a tap, you could essentially do the same exact thing here where it would then correctly do it. And again, this is kind of just a limitation, but a kind of workaround of some limitations. Then we have our other actions right here. So obviously the correct tap, a swipe, and then up whatever direction along with these, the swipe up, down, left, or right, type, and then wait. And we also had to specify here that when it wants to type something, it needs to first tap. So it's referred to here as like focus. You'll see it in the logs if you're running it. So it knows to tap first before it types in a text box. Otherwise, it will not have any place to actually enter the text. And then it just kind of handles more about like the coordinates and everything like that, and doing it all in kind of correctly actually executing whatever actions we want. Next up, we have UI, which this is just kind of the script to handle running the Gradio web interface. Something I should do, and if I forget to do this, I'll just show it right here. If it shows a live shareable link like that, this just needs to be changed right here to false. I will update the repository with that as well, but in case I forget. But this is just kind of the Gradio like boilerplate code for setting up the very simple web interface that we saw. And really following this, the only other thing is the OmniParser runner script. So this kind of allows us to run OmniParser without having to use it like in the Gradio way that's shown on the Microsoft GitHub. So this basically just kind of handles running OmniParser for us, and we don't really have to do much at all. And this just kind of, again, is a lot of this is lifted from the actual OmniParser repository at certain places or things of that sort. Hopefully that wasn't too long and verbose, but I did just kind of want to give a general overview of these scripts along with some of what they control, because if you want to go in and modify this and mold it to a specific use case, it might be helpful to just have some kind of surface level overview of said scripts. And really, that is kind of going to conclude this video. We saw obviously how it works from a workflow perspective and the nice Claude SVG right here, which may or may not be completely accurate, but it's good enough. And yeah, it is kind of fun to play with. And again, it is very experimental, so I can't guarantee the functionality on other cards or like CUDA versions or whatever, but it's something that can definitely be tweaked. And it was honestly just something fun that I've wanted to make. So I figured I would go ahead and also share it if it was at a level good enough to me, which was basically that it could open the phone's browser and search something and then like autonomously do actions. So with that, that is going to conclude this video. I hope that people find this interesting enough to actually use or find purposes or use cases to implement with this. And yeah, that's going to wrap it up. If you have any questions, please feel free to let me know. And thanks for watching.